chemists use molarity all the time when they're talking about solutions, and they do it for a pretty simple reason. We know how to convert anything into moles using molar mass. And the reason that we use moles instead of some other type of unit is because, let's face it, a mole of H2, for instance, is going to have a very different mass than, say, a mole of, I got a couple people coming in here, than a mole of NaCl. So we don't want to typically work in terms of grams. We want to work in terms of moles. And Stella, welcome. Just give me a quick heads up that you can hear me and see me.
I can hear you, but I can't see you.
Did we have this issue last time?
Yeah, I
Okay.
reached the page.
So I'm keeping my fingers crossed that that takes care of it for you there, okay? And if it doesn't go out, come back in. I'm recording it, so we'll get you hooked up, okay?
Okay, I can see you now.
Okay, and if you can mute it, that would be splendid. All right. So off we go here. If I want to talk about how much concentration of solute I have, this is the formula, all right? So molarity is capital M. And so if I have a certain molarity, if it's like a 3M solution, we would pronounce that 3 molar. All right, that's just it's a weird unit, but that's the name of it, and it is literally moles of solute divided by liters of solution. So two key points: make sure that you've got the solute in moles, and then make sure that you have this guy in liters. Those are going to be the places that you get messed up. So the formula is pretty straightforward. Molarity is number of moles over liters of solution. And I'm going to pop over here, turn off that sound making thing. And let's look at an example or two real quick. And then I think you guys are going to be really just fine with this concept. So if I said, let's calculate the molarity of a solution, I've got 32.5 grams of NaCl, and we're adding it to make 3 liters of solution. So step one here, as I've said, list the variables. This is a mass. So if we're thinking about determining molarity, we're going to want to remember that we want to convert mass to moles. We know the volume and we want to find molarity M. So down here, and if I'm just sort of in your shoes, I might just jot down this little step right here. I'm taking my 32.5 grams of NaCl. I'm multiplying it. This would be my sort of conversion. We're used to seeing it a little bit more like this. So I put my 32.5 grams of NaCl up here. This is my molar mass, 58.44. And we know that that is 1 mole of NaCl. And then you just do the math and then know that that's a little bit small, so I'll make it bigger. It's 0.556 moles. And then you remember that the formula is number of moles of solute divided by number of liters of solution. And if we were being really ticky-tacky, we'd be careful with sig figs here. I'd want 2 sig figs. So the answer is that this is a 0.19 molar solution. And the reason that this is important is because depending on how much solute you dissolve in, just like when we talked a couple days ago about dissolving Gatorade mix, that powdered mix, into water, you want it to be the right concentration. If it's too low of a concentration, it's not going to taste good. And if it's too high of a concentration, it's also going to taste not so great. So I'm going to pause there. Any questions about just sort of a basic calculation, throwing these guys into this formula here? And Stella, I know you were jumping in a little bit late. Stella, are you doing okay?
Yeah.
Okay. All right. So if it's all right with you guys, speak now. I'm going to go ahead and change pages. Okay. So second example here. how many grams of NaCl are needed to prepare this amount of solution. And it's coming from a 3 molar NaCl solution. So you read the problem and you write down what you know. First step is recognizing that the volume is 250 milliliters. We don't want to work in milliliters, so we move the decimal over 3 places. We know the molarity. And then since we're trying to figure out grams, if we go back to our formula, molarity is moles of solute over liters of solution, moles over liters. I should be able to do this equation and do a little bit of rearranging to figure out the number of moles, which is what I've got written down here. N is equal to M times V. So if N is equal to molarity times volume, and I know the molarity is 3, and I know the volume is 0.25, and that's what we end up with down here. So we end up with, this is 0.75 moles. And then we're like, well, it's 0.75 moles of what? Well, it was moles of NaCl. So if I remind myself that it's 0.75 moles of NaCl, we already did a problem, just this previous example, where we figured out the molar mass, and you know how to do that. You go and look at the periodic table. You've got 1 sodium and 1 chlorine, add those together. And so the last step that I would write down if I were in your shoes, I'd throw that little conversion onto my paper, and this would tell me that I'd have to have 44 grams of NaCl in order to create 250 milliliters of 3 molar solution. So I'll give it a second here. Go around the horn. Robert, does that look okay by you?
Yes.
Okay. Look at that. Fantastic sound. Jack, is that all good by you? Hopefully we'll catch up with Jack in a second there. Stella, are you doing okay?
Yeah.
Okay. All right, so I'm going to shuffle this over here because there's one other thing that I wanted to go through. So this is basically, I'm going to give you 2 parts of this formula, and you'll have to find the third, and you just have to remember how to convert between grams and moles. So in terms of making solutions, I'm going to sort of zoom through this here, all right? Because this gets at an important idea down here at the bottom. All right, so if we start with this idea that the formula for molarity is number of moles over liters, I can rearrange this and I can figure out that if I ever want to know how many moles of solute I have in a solution, all I have to do is take the molarity and multiply it by the volume. Now, I'm going to ask you guys a question here. I'm going to come to you, Stella, if that's okay. Stella, if I went into the kitchen and I had some powdered Gatorade mix and I put way too much powdered Gatorade mix into the water, it tastes super sweet, it's not very good. Is there anything that I could do to my concoction to make it maybe taste a little bit better?
So it tastes super sweet?
Yeah,
You
like
could add,
I put way too much mix in.
you could add more water.
Yeah, you absolutely could. And so the process, thank you, Stella. The process of adding water to something is called dilution. You are diluting the concentration because you're not changing the number of moles of solute. You're not changing the amount of Gatorade powder that you put in there, but you are most definitely changing the volume of the solution. So dilution occurs when you add water to a solution. So this idea of dilution is actually pretty cool because if I am in the business of shipping chemicals to a chemistry teacher, right? What we typically do is we'll order chemicals, we'll order really concentrated solutions because if they're super concentrated, that means that they don't have a ton of volume, which means they don't weigh as much and they're a little bit cheaper to ship. If I don't want to give my students super high concentration acid, which I don't, what I would do is I would add in a certain amount of water and I would lower that concentration to a safe value, which leads us to this idea of what we call the dilution equation. And it comes from this guy that if I know the molarity times the volume, that's going to give me the number of moles. So what we're going to do, I'm going to move this. And what we'll see is that this formula right here, right, and I'll write it down here. So if I take the molarity times the volume, right, and this is using D's and C's, so I can stay with that. So D standing for dilute, M times V for concentrated. And so this is what we call the dilution equation. And if I ever want to figure out how much water was added or how much of anything, you're going to have a problem where you're going to have three pieces of this equation and you're going to solve for the missing piece. You're going to solve for that fourth piece. So I want to go through one example problem and then that's going to take care of us for the day. But this is called the dilution equation. And if we look at this guy right here, right, it says how many milliliters. So if I kind of read through the problem, how many milliliters, that's a volume, of a 5 molar, so that's a molarity. Molarity is 5 molar of a 5 molar stock solution would you need to prepare. So this is another volume. Now, I just want to be careful here. If this is in milliliters, then this answer is going to be in milliliters. And that's okay. I can totally leave it like that, right? I'll leave this as milliliters. And then this is the molarity associated with that volume. So I have a molarity and a volume, a molarity and a volume. And so what I can do is I can say, look, if this guy is the concentration that I have, that is way more concentrated than this. So this would be my concentrated. So if I'm going MCVC, MDVD, right? I can go ahead and say, well, my concentrated molarity is 5. The volume is unknown. That's what I'm trying to figure out. The molarity of my dilute solution, that's a much weaker solution, 0.35 molar. And then the volume of that, I happen to know, is 100 milliliters. So these problems, the biggest place where students will get messed up is they put numbers in the wrong spots. Maybe you accidentally switch some numbers, you put them in the wrong place, and you just do some math, okay? I'm gonna pause for a second. Questions from you guys?
Yeah, so how do you know if it's concentrated or diluted? I'm guessing the D is.
Yeah, it's a
So
great question. So you look at these numbers right here. These are the concentration numbers. So 5 molar, 0.35 molar. So which one is the bigger number? The 5 molar. And so since that's the bigger number, that's going to be the higher concentration. If you spilled 5 molar acid on you, there's going to be a much more likelihood of that hurting you than the lower concentration acid. So you just look at the molarity numbers there, Stella. Does that help?
yeah.
Okay. Okay. All right. Any other questions there?